Hi, this is Andrew. Thanks for joining me. This is the third video in this subnetting series looking at how subnetting works from a binary perspective. And now we're going to actually move on to something that is just a little bit more, not a trick, but a technique on how to do this a little bit quicker. So we still have all of the same information from the previous video where we did subnetting and we looked at binary. And what we did here is we took these two digits and we cycled through 0001, 1011, because those are all other possibilities. Now, what we have here, if we take a look at it, the /26 means that our subnet mask is 255, 255, 255, 192 in that last that last octet. So we have a 1-1 there. That means a 1-1 here. What we can do is actually highlight this number and say, hey, this is our magic number. So we're going to highlight that right here. 64 is our magic number because that's where the last binary bit is in our subnet mask. And if you look at the networks we created, the first one is 0. Obviously, we start with 0. The second one is 64. We add 64. The third one is 128. We add 64 to that. And the fourth one we add 64 to, and we get to 192. And what we have here are these are the numbers we were cycling through in the previous video, where we had all of the possibilities here. We did 0, 0 here, 0, 1. And if we look at these numbers and convert them to the full 8 bits, we will see that all we're doing is counting in this case, that second position. So we go that, we add 1 to that, so we're just cycling through all of these. So we can just say we're gonna count based on 64 and come up with all of our network addresses. We don't need to convert anything to binary. So let's actually do this. We're going to start with a 24. We're going to subnet it into 26s. So we can eliminate all of this and we will come back to the same numbers, but we will say our network 1 net ID is 192.168.0.0, and we'll include the /26. Net 2 is 192.168.0.64 because we add 64 because that's our magic number. /26. Net 3 is 192.168.0.128, and if you remember, these are all the numbers we just saw. And net 4 is net ID, and that's actually not net ID. Let's fix that consistently. So we have 192.168.0.192 /26. So we've just did that subnetting, and all we came up with were network IDs. But if you remember, we have broadcast, and that is going to be one less than the next network. So we have 192.168.0.63. Our first and last, I'll do first and last on the same line and only talk about the last octet. This is really our range, 1 to 62. And then we have here, we'll do first, last, and broadcast. And now you can see why I do broadcast first, because all we have to do is look at the next network, 192.168.0.127. And then we have our range is 65 to 126. Here are first, last, and then broadcast is our broadcast 192.168.0.191, one less than the network 4, and we have 129 to 190. And then we finish up. And here we do first dash last, and we do broadcast. And here we don't have a next network to figure out what the next one or what the previous address is before the next network. But if we add 64 to 192, we get to 256, which we know is not possible. 255 is as high as we can go. But that really tells us that our broadcast is 192.168.0.255. That puts our first and last at 193 and 254. 254. So we just did exactly what we would have done with that binary. Now, of course, we were just repeating those steps, so it seems kind of, I don't want to say, it seems a little bit easy. So let's say we're not repeating the steps we did before. Let's say we're using a 27. And in that case, we don't have this situation. We have this situation. So really what we're doing is we have a 0, 0, 0, 0, 1, 0, 1, 0. Now, if you notice, there are going to be more of these. We will have 0, 1, 1. That's how we count, because we're only counting in the third spot. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. And then the next one after that is 1, 0, 0, 0. And then after that we have 1, 0, 1. And now we have 1, 1, 0 and 1, 1, 1. And what we have here, previously we had 4 networks. 1, 2, 3, 4, 5, 6, 7, 8 networks. Each time we add a bit, we double the number of networks. So now we would have 8 networks available. But let's correct this and go through our calculations. We're going to do 27, and let's just delete all of the stuff that is incorrect so we can go through completely. Okay, now we'll go through 4 networks. We don't need to go through all 8, but it'll be the same process. So now we're doing 27. 27 means our magic number is 32. And it is because we're counting in kind of this third position. If you look, 0, 1, 0, 1, 0, 1. Each time we're adding 0, 0, 1 to the first 3 places in this octet. So 0, 0, 1, and then we add the 1 in here, and that gets us 1, 0, and then we add the 1, that's 1, 1, then 1, 0, 0, so on. So our first network is obviously 0 / 27. Our next network that we want to figure out, we just add 32. And then we add 32 to that, and we get 64. We add 32 to 64, and we get 96. Now, since it'll help us with our broadcast, I'll do the next address here, and I'll just call it next, and that's 192.168.0.96 plus 32 is 128. So now as we go through, our broadcast is 31. Our first and last is 1 to 30. Our broadcast is 63. And our first and last is 33 and 62. And make sure you're not, make sure you're going one more than this, one less than this. You're going inside of that range we have there. That's an easy mistake to make and really throw yourself off. It's also really good to just go through and do all of the network IDs first. If you do throw yourself off, at least it's only in one octet or one network in that range. So 65 to 9, let's try that again, 94. And here we saw our next one was 128. So we have 127. And that means that our range is 95 to 126. So if I kept going beyond that, my next network is 128, and I could just list out all of the networks. The only reason I don't do it here is just it kind of confuses what's on the screen. So that really, we can do magic number no matter what we're looking at. If we're doing a /29, that would mean that we have a 1 in this position, we have a 1 in this position. Since we have 24 bits on the left side on the first 3 octets, now we have 5 more in this octet that are being used for the network. So it goes to the 5th position, and this is where we're counting from. And in that case, so I'll get rid of the rest of these because we're counting from there. Although our first one is 0, 0, 0, 0, 0, 0, 0, 0. Second one is this, which is 8. So now we'd be counting with 8. So our network addresses, let's highlight that. That's our magic number. Our network addresses would be 192.168.0.0 /29, 192.168.0.8 /29, 192.168.0.016, and we're counting up. And obviously with 5 bits, there are a lot of numbers that we have available there. So there would be a lot of networks there, and we would have broadcasts of 7, but with a lot of networks, we don't have a lot of host bits. So if our broadcast on this first one is 7, bcast 192.168.0.7, our range is 1 through 6. So there are only 6 addresses available. So next time I will talk about how to figure out how many addresses we have available, how to create a design that will fit the number of addresses available. And really that's as far as you generally need to go with IP addressing, is designing the network. But really this piece here covers most of your questions, because you will have questions that can be what's wrong with this design? So if I get rid of this and we go back to where we were in this design here, where we had a /27, we could have a question that is, we have this network design or this network configuration and what's wrong. And it could be 192.168.0.5 is on one network, and it's using a default gateway of, we'll call it 0.33. And those are on separate networks, so they can't work. Or we have a subnet mask that doesn't match. It should be a /27, which is a /27 should be 3 bits there. So a /27 is 128 plus 64 plus 32, 192, 224. So our subnet mask there would need to be 255.255.255.224. So that really will answer the questions. You need to figure out what your range is, what your network is, and then use those IP addresses that you came up with to define which IP addresses are used for which device, and make sure that they're on the right network, depending on what device they are. So that's all I have for you today. Thanks for watching.